In this video, we will talk about electrostatics and charging by friction. Stated briefly, electrostatics is the branch of physics that deals with static electricity. To get started, let's get two ebonite rods and suspend one of them by the thread of a stand. Note that ebonite is also known as hard rubber. We then rub one end of each of the two ebonite rods with a cloth of wool or fur. After that, we approach the rubbed ends of the two rods to each other, and we notice that the two rubbed ends repel each other. We can repeat the same experiment with two glass rods rubbed with a cloth of silk. Again, the two rubbed ends repel each other. We can also repeat the same experiment with both an ebonite rod and a glass rod. In this case, however, the two rubbed ends attract each other. So, how can we explain what happened? We know that matter is made up of extremely small particles called atoms. Every atom is composed of a nucleus surrounded by electrons carrying each a negative charge equal to minus E, where E is the elementary charge and is equal to 1.6 times 10 to the minus 19 coulomb. The nucleus is made up of protons carrying each a positive charge equal to plus E and neutrons that have no net charge. Protons are about 1800 times more massive than electrons and are not as mobile as the electrons. An atom has as many electrons as protons. Therefore, an atom has zero net charge. When an ebonite rod is rubbed with a cloth of wool or fur, a certain number of electrons migrate from the cloth to the rod. The ebonite rod has thus an excess of electrons. Therefore, it is negatively charged. When a glass rod is rubbed with a cloth of silk, a certain number of electrons migrate from the rod to the cloth. The glass rod has thus a deficit of electrons. Therefore, it is positively charged. This phenomenon is called charging by friction or electrification by friction. Note that charging by friction is due to a transfer of electrons. From these experiments, we can deduce that two electric charges of the same sign repel each other, and two electric charges of opposite signs attract each other. Note that the electric charge carried by a charged body is given by the formula Q equals plus or minus NE, where N is a whole number and E is the elementary charge. Thus, the absolute value of Q equals NE. Also note that during charging, the total electric charge is conserved. And this is all for this video. Thank you for watching.